Here is a question from JEST 2018. JEST 2018. There is a person on Earth and he observes two rockets A and B directly approaching each other with the speeds 0.8 c and 0.6 c. So there are two rockets. This is rocket A and this is rocket B. Rocket A is moving with the speed 0.8 c. VA is equal to 0.8 c. With respect to Earth we are talking. And VB, velocity of the rocket B, with respect to Earth, this is equal to 0.6 c. Now since it is in the opposite direction, we will put a minus sign. Now at a time when the distance between the rockets is observed to be 4.2 into 10 raised to 8 meter, the clocks of the rockets and Earth are synchronized to t equal to 0. So the distance between them, the distance between rockets A and B is 4.2 into 10 raised to 8 meter. This is when t equal to 0 in both the clocks of rocket A and rocket B. Now what is the question? The question is the time of collision of the two rockets as measured in rocket A's frame is x by 10. What is x? So we have to find out the time of collision in rocket A's frame. Time of collision in rocket A's frame, this is equal to distance as observed by A, distance as observed by rocket A, divided by speed of B with respect to A, speed of rocket B with respect to A. Now when viewed from the Earth, the distance between rocket A and rocket B is 4.2 into 10 raised to 8 meter at t equal to 0. But when viewed from the rocket A, the distance itself is moving in the opposite direction with speed 0.8 c. Therefore the distance will contract. You know that length contracts when it is moving. Therefore distance between A and B as observed by A will be equal to L0 times root of 1 minus V square upon C square. Here L0 is 4.2 into 10 raised to 8 meter. This is the distance as measured from Earth by an observer in Earth, times root of 1 minus V square is V is 0.8 c. The distance is moving in the opposite direction as viewed from rocket A with speed 0.8 c. You can put minus as well because it is in opposite direction, but when you square it will give the same value. 1 minus 0.8 c square divided by c square. This is equal to 4.2 into 10 raised to 8 meter times 0.6. Now velocity of B with respect to A, this is equal to VB minus VA divided by 1 minus VB VA upon C square. Now you can measure VB and VA with respect to any frame, but whatever frame you measure the velocity of B, you should measure the velocity of A also in the same frame. So we are taking velocity of B in the Earth's frame. Velocity of B in the Earth's frame is minus 0.6 c. Velocity of A in the Earth's frame is 0.8 c divided by 1 minus VB is minus 0.6 c times 0.8 c divided by c square. This is equal to minus 1.4 divided by 1.48 times c. Now speed with respect to speed of B with respect to A is equal to, when you talk about speed you will not talk about direction, so we are only interested in magnitude, 1.4 divided by 1.48 c. Now time of collision as measured in a rocket frame is equal to distance as measured by rocket A, which is 4.2 into 10 raised to 8 meter into 0.6. 4.2 times 10 raised to 8 meter times 0.6 divided by speed of B with respect to A, which is 1.4 divided by 1.48 c. This is coming out to be equal to 0.89 seconds. Now in the question, the time of collision of two rockets as measured in rocket A's frame is x by 10. So x by 10 is equal to, we are finding it to be equal to 0.89 seconds, which means x is equal to 8.9 seconds.